Let's build the Master's Forge. This video is going to document the assembly of the first electromechanical prototype. The first step is going to be taking these brain boards and attaching them to our endoskeletons. Here's an up-close look at the brain board PCB with its 4 straddle-mounted USB-C connectors. Here's the carbon fiber infused PLA endoskeleton. We'll take the 2 back USB-C ports of the brain board and we're going to stick them into these protected sockets here. And the mounting holes, as well as the pass-through holes for the exoskeleton mounting, should line up with all of the bosses on the endoskeleton. And we're going to use these into screws and this driver to attach it securely. I actually forgot one step. We need to attach 2 of these flat flexible connectors onto these 2 ports right here. And the way that you do that is you just pull this little black tab out, you slide the metal facing end downwards, and then you push that tab back in to lock it in place. Now the other one. These are going to connect the fingerboard as well as the thumb board to the brain board so that it can transmit all of your inputs to your computer. Now we can put it in. 1, 2, 3, 4, 5, 6, 7, all mounted. Alright, next we're going to take our exoskeleton and we're going to attach both the fingerboard as well as the thumb board. Because this exoskeleton is 3D printed rather than the metal ones that we've made, I went ahead and printed the spacers straight into the inside just to make that process easier, and also I printed the threads for each of these mounting bosses straight into the exo. Actually, I'm getting ahead of myself again. First, we need to put in the stem as well as the compression spring so that whenever we attach the circuit board to the exoskeleton that it's sandwiched in there and it won't move around. Let's start with the thumb board. I believe these are 10mm springs, 0.4mm wire thickness, so they're pretty light. Really it just is to make sure that these don't feel loose and that the auto homing geometry here in the exo is making sure that the switches are always facing in the right direction. Okay, put the compression springs right in the middle of this silkscreen target here and align all those holes. And use the same M2 screws as before. One, 2, 3, 4, 5, 6 screws, and you can see, if you look closely, a compression spring pushing the stem up against the top of the exo. And then here's the stem sticking out of the exo. I'll give you a little sound preview. Really nice. Next we'll drop these 6 stems into the fingerboard exoskeleton. In addition to the auto homing geometry that I already showed you guys, there's a sinusoidal perimeter around each of those stems just to make sure that whenever you're in between the switches underneath, that it doesn't press up against the switch housing rather than actually the actuation point of the switch. Now I'll add these compression springs to the fingerboard. We'll have a assembly jig once we enter production. However, for now, I'm just using these 2 metal brackets that I found to make sure that when the exoskeleton is placed upside down that the tips of the stems don't push them out of their hole, and these springs can stay facing straight up. Springs are looking good. Now we need to align the fingerboard top. Last one. Oh, that's a good view. Focus it. There's a lot of cool stuff about the Master's Forge. I think the switches, I don't know if it's my favorite, but it's got to be at least in the top 3. I love the switches. I love how they feel. I love how they sound. And I love that they're blue. Obviously that's not why we chose them, but I think they look great. Now we have both the endoskeleton as well as the exoskeleton, and we're going to attach the FFC cables to these ports on both of the switchboards. One minor change for the production version, we're going to rotate these FFC connectors so they're not facing the wall, and you can take those in and out without having to remove the board. I had accidentally put in the wrong size FFC for this half, and I had to take this whole board out and put it back in just to switch that out. Now is the cool part. We're going to be folding the exoskeleton over the top of the endoskeleton. Here's one of the earlier metal exoskeleton prototypes that we made. With metal, you really only have one chance to get that fold right because these is just the 3D printed fitment tests. We have a lot more flexibility here. We don't need a special folding jig. I can just hand, fold this over the curves just like origami. Getting ahead of myself again, I've got to put on these slotted rails first. Line that up. Very nice. And of course, these railings will be extruded aluminum, and the little dovetail profile there is what's going to allow all of our machined bolt-ons to be able to slide on and secure themselves around the perimeter of your device. And then these book-on rails also have that same interface, but we'll put those on after the exoskeleton. We'll definitely want to do any surface finishing processes on the top before we put the stems on so that we have a nice, flat surface where you can either do a brush finish or a blasted finish or some of those different options that I've showed you guys in earlier videos. The first fold we're going to do is this 90-degree bend on the outside, and then we're going to do a slight fold here, just a few degrees for this outer facet on the fingerboard. Nice. Now I'll fold back the shoulder port. It's also another 90-degree bend there. Other side. I'm almost at the maximum video length for TikTok, so I think I'm going to break this up into 2 videos. Sorry in advance for that, but I'll post it right after this, so stay tuned to see the rest. And as always, this is day 63 of Caracorder updates every day until the whole world can type at the speed of thought. Thank you so much for watching.